In this section, we'll be talking about all the forms of factoring. So, to begin with, we'll introduce a fact about the greatest common factor. We say the greatest common factor, or GCF, is the largest term that evenly divides more than one term. So, it's what the two values or two terms have the most in common. We call the greatest common factor. So looking at this example, we want to find what is the greatest common factor between these two in order to factor them. So looking at 28x to the fourth plus 20x squared, what you should be doing in your head when you're factoring a problem like this is breaking these problems down to see what values each of them have. So for instance, this 28x to the fourth, 28, if you were to do its prime factorization tree, you would get 2 times 2 times 7. And x to the fourth just means 4 x's multiplied to each other. X times x times x times x. And this is being added to 20x squared. 20 is just 2 times 2 times 5. Again, if you could find this quickly using a prime factorization tree. And x squared is just 2 x's being multiplied together. So what's common between this term and this term? Well, we have 2 2's in each term. So the greatest common factor will have 2 2's. This term has a 7, but this term does not, so that's not common. This term has a 5, but this term does not, so that's not common either. But both terms have 2 x's, so we will put 2 x's, which means the greatest common factor is 2 times 2, or 4, times x, or x squared. This is the greatest common factor, the largest value that we can factor from each of these original terms. So when you do that, I'll go ahead and rewrite this here. When you factor this out, what that means is you are going to divide each term by 4x squared when you factor out a 4x squared. So, when we factor that out, meaning we divide it from each term, 28 divided by 4 just leaves us with that 7 that we had left over. And x to the fourth divided by x squared, remember with like bases we subtract the exponents, that would just leave us with x squared. Plus 20 divided by 4 is 5. And x squared divided by x squared cancels off, leaving us with 4x squared times the quantity of 7x squared plus 5. And this is completely factored. All right, so that covered factoring the greatest common factor. So let's go ahead and try one more example that will lead into our next topic. Go ahead and take a minute and pause this video and try to see if you can figure out how to factor this using the greatest common factor. Okay, so looking at this, we want to find what's common between the two terms that are being added or subtracted, in this case added. And notice that in each case we are multiplying by an x minus 2y. That is our greatest common factor. So we are going to factor out the quantity of x minus 2y from each term. And when we do that, we will get x minus 2y times, and remember when we're factoring this out, it means we're dividing each term by that. So 5 times x minus 2y divided by x minus 2y will just leave us with the 5. Plus x times x minus 2y divided by x minus 2y will just leave us with the x. And that is completely factored. Again, remember when we factor these values out, it's just as if we're dividing each term by the factor we take out. Okay, so this example I said would lead into our next topic, which is factor by grouping. Factor by grouping says given 4 terms, meaning you're adding or subtracting 4 separate things, you're going to start by pairing them together. We're going to take 2 at a time and pair them and make sure that the 2 pairs are being added together. Once you do that, you will factor the greatest common factor of each pair. At that point, you are then going to check if the terms in parentheses match. If so, you will factor it out, just like we did in this step. And if they don't, then consider factoring a negative from one of the parentheses, if needed. Generally, when you get to this step, if they don't match, it's because they're opposite signs, which means you can just divide by a negative or factor a negative out, and that'll get you exactly what you need. All right, so let's go ahead and try that with the following example. We have 3x squared plus 12x minus 2xy minus 8y. We're going to start by grouping them together in parentheses and making sure that they are added. They always have to be added. They cannot be subtracted. So notice how I took this negative 2xy. Because we were subtracting it, I made it negative instead and added the parentheses together. Plus a negative is the same thing as minus 2xy. All right, so now that they're in this form, we can then factor out the greatest common factor from each of them. So for instance, the first two, what's the greatest term we can take out of each of these? Well, there's a 3 that divides into 3 and 12. There's also an x that divides into x squared and x. So that gives us 3x times 3x squared divided by 3x just gives us x, plus 12x divided by 3x gives us 4. And now from here, we want to find what's common between negative 2xy and negative 8y. Well, first of all, there's a negative that's common. Also, 2 and 8 are both divisible by 2. There isn't an x that's common, so we'll leave that alone. But there is a y that's common, so we will factor out that y, giving us minus 2y. That plus, we don't need it anymore, but if we had factored out a positive 2y, then we would put the plus here. So we have minus 2y times negative 2xy divided by negative 2y just leaves us with x. And negative 8y divided by negative 2y leaves us with plus 4. Now notice we have the same value in parentheses, so we are going to factor it out. And when we factor it out, what are we left with in each term? Well, we have 3x in the first term minus 2y in the second term. And this is completely factored. Okay, from here, we're going to introduce the most common type of factoring we'll deal with in mathematics, which is factoring trinomials. So, the first thing we'll introduce is the most common type of factoring, which is guess and check, but then we'll introduce a method that is more exact and requires less guessing and just has a concrete formula throughout. So factoring with guess and check is a very efficient, quick way to go about it, but it doesn't always work out very easily. So generally when we have something of the form x squared plus bx plus c, meaning there's nothing in front of the x squared, then guess and check is going to be the easier way to go about it. So we say factoring x squared plus bx plus c with guess and check, you're going to find two values that multiply to equal c. And then from there, you're going to check that they add up to equal b. And the important thing to note is if c is positive, then they both have to have the same sign. So if c is positive 6, for instance, then the two choices you have to make both have to be positive numbers or they both have to be negative numbers. If they were opposite signs, if they were a negative 3 and positive 2, when you multiply them together you would get a negative 6. But remember, we said it was positive 6, so that would be impossible. So if c is positive, they both have to be positive or both have to be negative. If c is negative, then they both have to have opposite signs. One has to be positive, one has to be negative. And exactly how this sounds, this is purely a guess and check method. You're going to give your most educated guess and then check to see that it worked out. So when we factor x squared minus x minus 6, we will start by saying that we know the two values that multiply to equal x squared are x and x. This will always be the case when we're dealing with a problem that just starts with an x squared. And now we just have to figure out the two numbers that go with it. We need two numbers that multiply to give us negative 6 and add up to give us this negative, meaning negative 1. Because this is a negative 6, we know that they have to be opposite signs. So one has to be positive, one has to be negative. So think for a quick moment. Can you think of two numbers that multiply to give you 6, where one of them is positive, one of them is negative, and when you add those two values together, you get a negative 1. So hopefully the values you came up with were 2 and negative 3. This is supposedly the factored form of x squared minus x minus 6. This was our guess. Now we will check it. If we go through distributing this x, so I'm going to rewrite it. Since this is our answer, I don't want to do any work on it. If we distribute this x, and then distribute this 2, x times x gives us x squared. X times negative 3 gives us negative 3x. 2 times x gives us plus 2x. And 2 times negative 3 gives us minus 6. And when we combine our like terms together, we get x squared. Negative 3 plus 2 gives us minus 1x, or minus x, minus 6. And note, we just got back to the original problem we started with. That means it checks out. This is the factored form of the problem. Let's go ahead and try another one of these. we're going to factor x squared minus 6x plus 8. I want you to take a moment, go ahead and try this out, pause the video, see if you can get through this. Okay, so going through this together, remember if it just starts with an x squared, it's going to have that x and another x in parentheses. Now we need two numbers that will multiply to give us positive 8 and add up to give us negative 6. Well, because this value is positive, they both have to have the same sign. And because this number is negative, that means they both have to be negative. You can't add two positive numbers together and get a negative. So we know they'll both be negative. Now we just have to decide what two values. So can you think of two numbers that multiply to give you 8 and add up to give you 6? It'd be 4 and 2. And it is perfectly okay to put them in either order. I know that's a common question that comes up with this. X minus 2 times x minus 4 would have been perfectly okay as well. Now we just want to check that this works out. If we distribute these, we'd get x times x is x squared. X times negative 2 is minus 2x. Negative 4 times x is minus 4x. And negative 4 times negative 2 is positive 8. Combining our like terms together, we get x squared minus 6x. Negative 2 minus 4 is negative 6. Plus 8, which is exactly what we started with. So we have found the correct answer. Just to be clear, on any quizzes, homework, or tests, make sure that if you use the guess and check method, you show the check. Otherwise, there is no work to show for these problems. So you always want to show the check when you use the guess and check method. All right. At this point, we can introduce the other method, and there are quite a lot of these. But I'm only going to be going through these two methods because they cover both cases, the fast and efficient way, or the way that takes a long time but has no guesswork involved. Okay, so the no guesswork method is called the middle out method, sometimes referred to as the AC method. And what's nice about this method is it's very useful when you're factoring something of the form ax squared plus bx plus c. Remember when we were factoring these problems, it was just an x squared. Now it's okay to have a number in front of x squared. Just to be clear, it also works out with guess and check when you have a number in front of x squared. It's just outrageously more difficult, especially if that number is very large. So the AC method makes this process so much easier when we have a number in front of the x squared. The process says we're going to start by multiplying a and c together, this value and this value. When you do that, you are then going to find all pairs of numbers that multiply to give you AC, the value you got when you multiplied them together. And at this point, this is going to be very similar to what we did with guess and check. If C is a positive number and B is positive, so if both of these are positive, you're going to check which two values in step 2 add up to equal B. But if C is positive and B is negative, then you're going to make all of the values in step 2 negative, and then check which two add up to give you B. And finally, if C is negative, you're just going to subtract all of the values in step 2 to see which gets you to B. At this point, you're going to put an X with each of the values in the pair that worked out and replace BX. You're going to replace your middle term. So now instead of 3 terms, you will have 4. And remember, when you have 4 terms, you can apply factor by grouping. So it changes the problem into a much easier form of factoring, which is factor by grouping. So let's give this a try. We're going to factor 6x squared minus 17x plus 12. A very intimidating problem if you're using guess and check. Not impossible, and I'm sure some of you would be able to do it with guess and check. But we'll show just how much easier it is with the middle out method. So our first step is to multiply a and c together. So 6 times 12 gives us 72. And now we want to find all the pairs of values that multiply to give us 72. We're going to list them all. So we have 1 times 72, 2 times 36, 3 will divide into 72. 3 goes into 7 2 times. We have a 1 left over. 1 goes with the 2. We get 12. 3 goes into 12 4 times. Okay, from there, 4 goes into 7 once. We have 3 left over, a remainder of 3 when we divide into 7. 3 goes with the 2, we have 32. 4 goes into 32 8 times. From here, 5 does not go into 72 because it doesn't end in a 0 or 5. So we go to 6. We know 6 goes into 72 12 times because we just multiplied them together. 7 does not divide into 72, but 8 does. And it goes in 9 times. And the really nice thing about this method, as long as you go in this order, is once you get 2 values that are right next to each other, you have listed all of them. Now you just need to list them in the reverse order, meaning 9 times 8, 12 times 6, 18 times 4, 24 times 3, 36 times 2, and 72 times 1. Like I said, this is a long process. There's no doubt about it. But it is a worthwhile process, and you'll see why in just a moment. At this point, we said if C is positive, then that means we are adding all of the values together. And they will all get this sign of B. Since B is negative, they will all be made negative. And as you get better and better at this process, you won't need to check every single scenario, but this is just showing you that there isn't any guesswork technically involved. Alright, so from here, we now need to check which of these pairs gives us negative 17. So if we start going through our list, negative 1 plus negative 72 is negative 73. That doesn't work. Negative 2 plus negative 36 is negative 38. Still no good. Negative 3 plus negative 24 is negative 27. Nope. Negative 4 plus negative 18 is negative 22. We're getting closer, but still no. Negative 6 plus negative 12 is negative 18. Negative 8 plus negative 9 is negative 17. And that's exactly what we needed. Note, negative 9 plus negative 8 would also work. So either one of these will work perfectly well when we plug it back into the problem. I also want to note that if you did make sure you had every single pair in this list and none of them worked out, that means the problem doesn't factor, which is also a very nice thing about this middle out method. It will make sure that it gives you a yes or no answer, whether or not it can be factored, Whereas guess and check, you just might not have checked all of your possibilities. All right, so from here we said we are going to put an x with each of these values and use this pair to replace the middle term. So we have 6x squared, and instead of minus 17x, we're going to plug in minus 8x minus 9x plus 12. And now we are going to apply factor by grouping. We're going to group together 6x squared minus 8x and negative 9x plus 12, and we are going to make sure they are being added together. We will then find the greatest common factor between each pair. So, the greatest common factor between 6x squared and negative 8x, we can take out a 2 because both values are even, and we can take out an x, which gives us 2x times 6x squared divided by 2x is 3x. Negative 8x divided by 2x is minus 4. And from here, notice we have a negative first, then a positive, and here we have a positive first, then a negative. This is the note I made earlier, where sometimes you need to factor out a negative as well. So we're going to factor out a negative 3 is common between 9 and 12, and nothing else is common since they do not both have an x. So we get minus 3 times negative 9x divided by negative 3 is positive 3x, and 12 divided by negative 3 is minus 4. Notice that both values match in parentheses. Now we can factor it out. And what's left in the first term? 2x. What's left in the second term? Just the minus 3. So the factored form of 6x squared minus 17x plus 12 is 2x minus 3 times 3x minus 4. And that is completely factored. There was absolutely no guessing involved. So if you're someone that does not like the guess and check method, or you have trouble picturing what values multiply together and also add to equal the middle number, then the middle out method is a very efficient way to go about factoring. It just does take a bit longer. All right, so from there, I'd like you to take a moment, go ahead and pause the video and see if you can't factor 3x squared minus 2x minus 8 using the middle out method. Okay, so trying this together, first we multiply 3 and 8, which gives us 24. And now we find all of our multiples to get to 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 does not divide into 24, which means these two are the closest values you can get to one another when breaking up 24. So that means we can just flip our list. 6 and 4, 8 and 3, 12 and 2, 24 and 1. And now, because 8 is negative, we said we would just subtract all of these values to see which combination gives us that negative 2. So our first combination, 1 minus 24, gives us negative 23. 2 minus 12 gives us negative 10. 3 minus 8 gives us negative 5. 4 minus 6 gives us negative 2, and that's exactly what we were looking for. Note, in this case, it does matter if you flip the combination. In the last one, negative 8 plus negative 9 was the same thing as negative 9 plus negative 8. But in this one, 4 minus 6 is negative 2, 6 minus 4 is positive 2. We needed a negative 2. So be aware of that. Okay, so from there, now that we have our combination, we're going to put an x with each term. And just a quick note on that, you always put whatever letter is here. So sometimes you'll see things like minus 2xy. You are going to put an xy with each of these terms. Just always put whatever letter is here. Okay, so with that, now that we have our letter with each term, we will substitute it in. This is why we call it the middle out method. We take the middle out, we replace it. So that gives us 3x squared, and instead of minus 2x, we have plus 4x minus 6x minus 8. Note that the problem hasn't changed. 4x minus 6x is negative 2x. We've just rewritten it, which now allows us to apply factor by grouping. So we will group them in parentheses, 3x squared plus 4x, and we need to make it addition, so we're going to group this negative with the 6x. From here, we'll factor out the greatest common factor of each pair. Between 3x squared and 4x, there is only an x in common, which gives us x times 3x plus 4. And now what's common between negative 6x and negative 8? Well, there's a negative that's common. And also both numbers are even, so there is a 2 that is common. So we get minus 2 times negative 6x divided by negative 2 gives us positive 3x, and negative 8 divided by negative 2 gives us plus 4. We check if the values in parentheses match, which they do, so we can bring 1 down, 3x plus 4, and then we check what's left in each term. In the first term, there's just an x left. In the second term, there is a minus 2 left. And this is the factored form of 3x squared minus 2x minus 8. So from here, we just have a few rules left to talk about. These are special factoring cases, which allow us to skip guess and check or middle out method. This first case is one that we've talked about in a previous video when we were multiplying polynomials. This is the difference of squares case. It's one of the most important factoring cases there is. It comes up in all types of math classes. If you have a squared minus b squared, this will factor into a minus b times a plus b. You take the square root of each term, and you just plug it into this formula. The second and third cases are not as common, but still very useful. The first case is the addition of cubes formula. So a cubed plus b cubed gives us a plus b times a squared minus ab plus b squared. And the difference of cubes formula gives us a minus b times a squared plus ab plus b squared. The nice thing about these formulas is they are essentially the exact same thing, except you just swap the signs of the first sign and the middle sign. Notice this is positive, this is negative. In the second formula, this is negative, this is positive. Everything else is the same. All right. So with this, let's go ahead and factor these two problems. The first problem, 4x squared minus 9, we're going to check if this could be a difference of squares by just quickly taking the square root of each term and seeing if we find that these are perfect squares. If they are, then we can apply the formula. The square root of 4x squared, meaning what value multiplies to itself to give us 4x squared? Well, the square root of 4 is 2, and the square root of x squared, if we ignore absolute values, which we don't need to worry about right now, is just x. And the square root of 9 is 3, so notice these are perfect squares, so we can apply our formula. Our formula says take the first value, 2x, and subtract the second value, 3. Then again take the first value, 2x, and add the second value, 3. And this is completely factored. Just a quick note, middle out method would still work here. You're finding what combination multiplies to give you 36, and then when you combine them, gives you 0, since your middle term is 0x technically. But it is much better to memorize this formula, as this will come up a lot, and you need to know how to quickly approach these problems. From here, we now want to factor x cubed minus 125. So to do this problem, hopefully it's going to match up with the third case, a difference of cubes. We just need to check if the cube roots exist. So the cube root of x cubed we know is just x, and the cube root of 125 we could rewrite as the cube root of 5 cubed. Remember, 125 is just 5 times 5 times 5 if you did a prime factorization tree. So we just get 5 cubed, and now the cube root of 5 cubed gives us 5. Both of them are perfect cubes, so the formula works out. We get the first term, x, minus the second term, 5, times the first term squared, x squared, plus the first term times the second term, x times 5, plus the second term squared, plus 5 squared. And simplifying this, we get x minus 5 times x squared plus 5x plus 25. And that is completely factored.